Hi, I'm Cindy Pearl, and this week Don and I had the pleasure of meeting Mr. T.R. Knudsen, who was one of 7 men responsible for the discovery and development of Brown's gas, which is a source of energy derived from water. Of the 7 men who participated in developing the use of Brown's gas, 6 are no longer living. Mr. Knudsen himself is believed to be dead due to an explosion. However, he is still very much alive, as you will see. So we met with him in a scenic spot where his boat is moored, and his boat is also a topic for discussion. Our good friend John Ballou introduced us to Mr. Knudsen and is also participating in the video. So enjoy. We're hoping that we'll be able to learn a lot from Mr. Knudsen now and in the future.
And, and this is Don Pearl.
Feathers.
This is Don Pearl, our scientist. One scientist and another scientist is Knudsen. And Knut, you actually said your native name was your Osami. Could you explain what Osami is?
Sami is, or Sami is the native Caribou peoples of the center and north. They are the supposedly the keepers of the flame. Also, it's indigenous to Norway, Sweden, Finland, and Russia. And
would they be considered the Laplanders?
Yeah.
Is that kind of a generic name?
Yeah, it's kind of a bad name.
Okay, sorry, bad name.
Yeah, so
well, that's what I was taught.
Right. Yeah,
a bad name.
People, right.
Okay.
So so that's my heritage, and also then my last name, Knudsen, means I'm a direct lineage of King Canute, the fellow that they said forbade the tide to rise, but we are told as a family story that he wanted to prove that he was not a god walking among men, as Pope Benedict of the day told him he was when he said that he could be king, but rather a human being who had conquered England.
Didn't you also tell me something that it was tied into the tribe of Dan?
Mm-hmm. Denmark, yeah.
From Denmark?
Yeah, Denmark. The tribe of Dan had this habit of naming everything after them when they would travel, like the Jordan River comes out of Dan. The tribal area, there was the Creed to Dan. The tribe of Dan was given the knowledge of how to make the Ark of the Covenant, an electric device that talks to God, or God talks through. Also that, like Sardinia, Macedonia, the Danube, Sweden, Denmark, Mark of Dan, all of these places, even Sicily actually.
Do you think, okay, let me just ask you, this is just an interesting question, is that, do you think because there's this relationship to the tribe of Dan, it might have something to do with this gas?
Oh, absolutely, because knowledge comes through your blood. We don't know what is in the middle of the DNA. I know that nature wastes nothing. So when a DNA scientist turns to me and says, well, 95% of it is garbage, and it's just these few little things that we need to know about. The rest of it just seems to be so much muddled code. I don't think that nature does that. I've never found an experience in nature that it doesn't teach something. We know, until we examine something, we call things in very broad terms, like we call instinct. What is instinct? How does a baby tickled here know to turn and suckle? How do they know you blow in their face when they're born? Which you don't have to spank them on the fanny, you just need to blow cold air in their face, which would be a facility of birth in itself, and it would normally bring them right to their intake of their first breath. So you just go, I forget the startle effect.
So it just seems to me, I'm sorry.
Yeah, DNA, I think it comes through the blood.
It just seems like this is such a great invention. Now, couldn't this actually supplant a lot of the power systems that we have today? And if so, why hasn't it been embraced?
Well, I think there has been eons old effort to repress it, such as the Great Pyramid means actually fire mountain. You know that, right?
Yeah.
If you look at the bottom of the pyramid, you're going to find huge crucibles. The crucibles have a hole drilled in the side of them to allow slagging.
They never knew what those.
Never knew what those crucibles were. They're actually smelting crucibles. The pyramid, because it has no inscriptions inside, it's not an ancient burial site. It's not a temple. It's not anything else other than a furnace. And that's why it always has been named Fire Mountain. It is a hydroxyl furnace, and they've known about this from time immemorial. Hydrogen forever. The first welding process in the world was a hydrogen-oxygen welding process in about 1856, I think, if I'm not mistaken. So before oxyacetylene, before propane acetylene, or propane-oxygen welding, there was hydrogen-oxygen welding. So it's kind of like we've had the knowledge all around us all the time, and also the infrastructure. The Germans found out about hydrogen brittlement and the valves and what you had to do for shipment, the pipes, the piping, the storage containers. All of that was basically pioneered by the metallurgists of Germany. And so he said, just make your own hydrogen. Make your own hydrogen? Because I was going to Libby Glass, a friend of mine's father worked there, and he would fill up small bottles of hydrogen for me, and then I was trying to get the temperature up on my little foundry that way. And so I went from trying to make this Jim Bowie type knife to really getting into a serious study of making steel. What I was able to find is that, of course, carbon content changes the steel itself. If you're under 2% carbon, you get a very brittle steel, but a very hard steel, one that holds a knife edge really well. Above that, you get wrought iron, and very flexible, it bends easy to work, and all that stuff. But by going to those two knowns as far as percentage and quantity, you can combine them. Once those are purified to that, you can combine them in ratio, and you end up with exactly what you want, either hardness, brittleness, whatever, like the samurai. Hammering in enough carbon gives you a certain type of edge, a certain type of ability, a certain type of flexibility. Lamination, much like the Damascus process or the samurai process, by laminating, folding the steel, and pounding it, and working it, you get flexibility and strength. So anyway, I developed about 3.5 ounces of steel, but I used the electrolytic process of Michael Faraday, English inventor and researcher,
chemistry,
right?
A long time ago. Yeah.
And but I was using the gas as one single gas, the hydrogen gas, and the oxygen I was letting go to waste. The thing about that was that I was very proud of myself again. Always when I'm full of myself, something else comes along and kick me in the knees and say, you better look at yourself again. So the idea was that I was like a tree. I was making hydrogen for an industrial process, and I was letting the oxygen go into the atmosphere and be happy and give to something else. And I thought, oh, aren't I wonderful? And then, but I was buying oxygen to add to the process because it was a hydrogen-oxygen process in green bottles. And finally a kid showed up at my door, the garage, and he says, Nude, or and he called me Mr. Knudsen because I was tall then. He says, Mr. Knudsen, why are you making oxygen from water and hydrogen, but you go out and you have to pay for the green bottles that you have sitting here to add back into it because you've wasted the oxygen to the atmosphere? And so I went, duh. And so I said, thank you, and I turned around and he was gone. And never came back, never saw him again. And so I went, okay, we have two gases, why not use them together? There's one gas in a common ducted tube, because it's already in the exact ratio that is needed because it just came from water. To reach stoichiometric mixture means it burns totally and goes back to water when it burns. And so a little epiphany thing thanks to a little 9-year-old kid that came to my garage door, you think, or the vision was. I like the irony. I like irony on myself. I even think back about it now. I'm looking back and saying, what was that?
Yeah.
I learned not to question so much.
Yeah.
Mystery is cool.
It's a gift.
Mystery
it was a gift.
is cool.
Yeah.
Mystery is cool. So anyway, I began to make steel from that using that process of wrought iron, high carb or a low carbon iron, and then mixing it together in measured, just like a measuring scale, weight and ratio, to get whatever effect I wanted. I wanted a sharp edge steel or a flexible steel, and then more. The interesting thing was when I used the hydroxyl process, hydroxy, or brown, what comes later in time to be known as Brown's gas, it never rusted. And I could make a lot of it. I could make a little, I could make a lot, and it was very easy. I came up to temperature within seconds. I could get my molten mass in just a very short period of time. It was reacting like nothing I had ever seen, and by this time I had been using propane, I had been using oxyacetylene, I had been using all of these conventional fuels that I could get my hands on. So, and it was just an interesting quirk of fate. But then anomalies began to be noticed, like you could hold it near your hand and you would only feel a warmth. Later on, we thermographically registered the gas at only about 259 degrees Fahrenheit. And yet you'd put it to a stone and it would go white hot, incandescent, instantaneously. So most of thermographics is known by temperature, known flame or heat source, and time. It takes this much time, like cooking a turkey. It takes this much time at 375 degrees to equal this much result.
Yeah.
Hydroxy was nothing like that. Hydroxy was, you could only char like carbon or paper or other things like that. Barely char it. It's difficult to heat water because the water, of course, is moving out, but there was very little reactivity with water itself. Yet you turn right around and put it to aluminum and you're getting 950 degrees, slightly above the melting point of aluminum. You turn it to stone, you're getting about 4,000 degrees. You turn it to tungsten steel and it's sublimating tungsten steel, meaning that it takes it from its solid state, cold, to a gaseous state without passing through a molten state, and it immediately goes incandescent and vaporizes into its oxide, which is about 5,900 degrees centigrade, or about 13,000 degrees Fahrenheit. And we know that the sun's surface is about 950 or 9,500 degrees Fahrenheit. The corona is the part, or is the part that develops the millions of degrees that we see as radiant heat. The surface is about 9,500 degrees, so this is about 1.2 times the surface temperature of the sun. But you can hold it in your hand and you experience only 259 degrees. And we think that's only because of the interactivity with conventional air, that there is something taking place in the conventional air, or it would have no temperature. It also contains its oxide, so fuel and oxide, it will burn in a vacuum without degrading the vacuum except to the volume of the reduced water after it burns.
So it just seems so odd to me that I've studied a few other things about this, about other sources of power, and it just amazes me that we could have a planet running. Isn't it true we could have a planet running on
Absolutely.
endless amounts of power without all this destruction?
The making of steel. Eventually I wanted to go green with this whole process, so I unplugged my unit from the wall more or less and got solar panels from Radio Shack. Shameless plug, Radio Shack. And I made my steels using nothing but solar power, water as a fuel, and the ore base that becomes the steels. So, but that was just basically to demonstrate that you don't need these coal company and the other company, and what I think by that time I was about 17 and could afford the very expensive small solar discs to make my own solar array back in the day. And I didn't know you could buy solar panels. I just knew that you could buy these little discs from Radio Shack.
Well, didn't you then, you obviously made all this, and you got this going, and I understand you had a group, and you put this together, and you demonstrated it worked. So how did they stop you?
No, they didn't. I got an A.
Oh.
But also, I mean, on my high school project, got an A in chemistry on it, making steel with
So
solar power.
is this gas out into the world?
We started another group, and basically we began to know of each other because it's a very narrow field of research. You know, are you into oxyhydrogen? Are you a hydroxy maker? And so we began to communicate basically by the day mail was the only way. In fact, when Brown and I first met in '83 or '84.
Is Dr. Brown?
Yeah, Yul Brown. I went to Sydney Airport and he went to pick me up. And when I got there, he said, "Well, I thought your father was coming." I said, "No, it's me," because we never exchanged ages, you know. And he thought he was talking to somebody, you know, that had been in the field a long time, college graduate, etc. And I'm saying, no, I'm a college dropout, and I'm an idiot, and this is how old I am. But
how old were you when you met him?
Oh gosh, let's see. 33.
33.
33 years old. I never thought about that, but there are numbers that are sequential.
Yeah. So you've got the group together, and now I understand that Brown's Gas though is in how many countries?
Brown's Gas is now actually I have taught it in 65 countries for free. That was always our. Later on, we had, I guess you would call, spiritual experiences, and that connected us all because we had a similar vision of what we called a blue rose.
That's fascinating. A blue rose.
Yeah. And
did you all see it?
All of us, and it was always around water, always independently, always.
Is it a flame? He says, "What is a flame?
Flaming
rose?
Actually looks much like a rose, but more ordered nature to its petal. I would describe it as like the spiral aloe of Lesotho in South Africa, that it has that spiral twist of the clay, and it is always transparent. I was in the bathtub. It's always around water. I was in the bathtub and I could see my toes through it, wiggling my toes. And it has silver and gold sparks, but it seems to be expanding and contracting at the same time. Never saw the vision again. But it was one of those things where even before you could formulate the question, the answer is in your mind. With me, I was questioning things like, what is time, what is reality, you know, and literally it imparted to me, and I say it because I don't want to say masculine or feminine, because I never got that sort of a feeling, but certainly capacity, you know, that
intelligence or something.
So did everybody have they had a similar vision?
Right. One Brown's, I think, was at a waterfall.
Yeah.
Dr. Smith was in his shower and he was put back by it. He moved back to the shower thinking he didn't want to touch it. It was always by water, a pond, a lake, or whatever, and independently. We all saw the same vision independently, separated by decades on different continents, but we never saw it again. It was like this one-time event. Yeah. And we tried seances, and we did. We tried every methodology. Voodoo, chanting in circles.
Voodoo. Okay.
Yeah. Because we all knew that we had felt something special, but also that became a signet or a kinship that we knew who we were talking to, someone else who was approached by this vision. And so it left 7. And
are you the only one left?
Yeah, I'm the only one left alive. So. Of course, you don't go talking to people about this vision where your toes are wiggling as you look through this blue, and it's an intensely dynamic blue. I've seen it, you know, it's like polished blue cotton. It has that iridescence quality to it, but it's just vibrant.
Can I ask a question?
Super high level energy.
Does the gas ever burn blue?
It can be seen as blue if it's seen through full spectrum radar, and that's one way they can detect it for protecting aircraft from this being used. It resonates at its own frequency, so you can make a device to keep you know, vessels of it off of an aircraft, so we can protect our aviation industry. But it's like, you know, you talk about something like the Blue Rose experience, or this Blue Lotus, or whatever you want to call it, experience, and then you say, by the way, I know how you can protect your airlines, and then they go, before, I'm on a no-fly list, so I just live with that. But I can't talk to them. Who do you go talk to?
No, no.
The Blue Rose told me to come talk to you and tell you to keep our airlines
Well,
clean.
wasn't one of the things, one of the stories you told me is that because this is so powerful, if you know how to use it, it's so powerful.
Split the earth in half with a swimming pool.
Right. So that's let's put that down as a slogan. So because it's so powerful, though, they thought you were a terrorist or potential
No, actually,
terrorist.
they just don't want it out there. I mean,
Okay.
we're supposedly
but they
at
use
war.
it potential
Right,
terrorists.
let me give you an example. We're supposedly at war because of 15 individuals from Saudi Arabia and a couple others that banged into a building and literally attacked our country and everything like that. So is it such a stretch to think that a Saudi Arabian hit squad would come looking for people like me that would literally depose all of the income of their entire nation?
Well, whoever set up the farce could do whatever they want to continue the farce.
Exactly. So I think they still want what knowledge is in here.
Oh, yeah.
And by my cell phone, which tracks me anywhere I go within 3 feet, they can keep track of me, and I don't have to have a chip. That's why I don't get into conspiracy theories, because I'm a conspiracy theory walking. So why put a chip in when you got this? And I bought this.
And you still carry it around.
Patents in 32.
30, yeah.
And
a number
I
of
taught in
places
65.
know this, so there's a
I
lot
went
of
open
protection
source.
in
Yeah,
that,
yeah.
where
I
you're
went
multiplying
open
the
source,
knowledge,
yeah.
and so how are they going to cut it off? It's going to grow organically.
Well, they tried to. They tried killing everybody. They killed Brown. They killed Stan Meyer.
But you're right; it's all over the place now.
But that was the protection, was give it out to everybody. But that's also what we're told by the Blue Rose. Make money on your machines, make money on the technology, make money on steel making process, but don't make money on knowledge.
Bless you.
So that was the edict or guard or thing that we all were exposed to also, or imparted to.
You teach it for free.
Teach it for free, but if you want to make money on the other things that it does, you're wide open, go for it. But let everyone know this for free. Always teach it for free. Always put the information
I can
out for
say
free.
that is since
Still
I've known
today,
him.
Still today,
this
that's
is
exactly
this is
the way
the
I handle it.
edict. Is that he will not make any money from the technology that way. Yeah.
And is everybody else that you've taught doing it the same way?
Yes. Brown always said, our machines cost us $2,000 to make. We'll sell them for $6,200. That will finance it. But along with the machine came principles of hydroxy or principles of Brown's gas, how it works, how it's evolved, what you could do to, if you wanted to, the basic principles, the patent, the drawings, and everything was all given with the machine for free, because we want them to know how the machine works. Makes sense. And also instruction manual, repair manual, and all of that sort of stuff.
How dangerous is it? You're on a boat. Is it, you're going to burn your ship and sink?
No, it's,
how does
this
actually work?
This is a very similar thing to the Blue Rose. It requires a high energy blue-white spark to do it. But you can take a milliamp spark and do that, like the spark that you see in the little piece of mercury in your thermostat. If you have the lights off, you can see this little tiny spark. That will set it off. But under certain conditions, it has to be enclosed. And I have a DVD that I can give you of our old work all the way back in the 1970s. That also includes footage when we were getting ready to go to China with our first BG-2000 that came out of the Australian factory. So we actually did violate the essence of our thing. We charged China $1 for the technology for all of China. But that kept us out of a problem with the federal government in releasing highly technical information to, at then, a quasi-enemy. And put us into the Department of Commerce. So, but they kept saying, well, you might as well have just given it to them. I said, we didn't. We charged $1. We did not give it to them.
Sometimes you need to play new games like that.
And it was a stupid game, it was a foolish game, but we did it, and it kept us out of prison.
Well.
But dangerous, you need the specific pressure to be just right. You a flame or a incandescent thing like a cigarette will not light it until you get right down to its source of emission. then it'll ignite. You can't develop, because it's so fine in its makeup, atomic level hydrogen and oxygen, you can't even get enough of it stored in a room to cause. It just leaks out of every tiny crack and whatever. It's breathable, so you can actually breathe it, which you get like hyperbaric therapies from it. It'll promote healing. It's exactly the ratio that the body needs, about 33% by ratio oxygen to 2/3 hydrogen. It also means you can eat through your lungs, because the hydrate goes into your bloodstream, and you don't even have to break it away from the sugar. It goes directly to the cells where the hydrogen and the oxygen combine in the cell, releasing water into the bloodstream and carbon dioxide into the bloodstream, but it provides you with energy.
So can I ask you, so it sounds like even with all the work you guys have done, you just scratched the surface.
Oh, absolutely.
So you want to pass this on?
Sure. Yes. Hello. I want to pass this on. That's why we're taping this. You've got it. Let's say you have a table of science over here, and you have vitrification of clay, and the making of pottery, and all the making of steels, and heating the home, and baking bread, and all the things that we do with steel. Rarefication of materials, rarefication of metals, consumption of metals, consumption of waste, and other things like that. Incineration. All that is this side of the table. On the other side, now you have a reductive flame that produces twice or 5 times the temperature, but in unique qualities that are elementally reactive. So now you can discriminate materials, you can make ceramics maybe better, maybe not as good. One flame can be better than the other. And so it's just like man and woman, yin and yang. You've got your, whose duty is this? The task dictates the duty. If we want to heat a metal, let's use the feminine flame. By the way, because of
There's
its
a
quality,
feminine flame?
So
that's what we
there's
call
different flames.
hydroxide.
You call it feminine
Well,
flame?
yeah, the one that we know of outward and push, shove, and the dynamics, injection of heat rather than asking for heat from the material itself is the masculine. Anything else we know, up, down, right, left, in, out, forward, reverse, positive, negative, S and base, all seem to have the opposites. Fire didn't. We think we've discovered the feminine side of fire come into me, contractive, interreactive with materials, not
explosive.
Not forcing,
Yeah.
Wow. Implosive.
Yes, implosive.
Implosive. We coined the term imbustion because it's implosive combustion.
Wow.
So the name hydroxy was my name given to it over 40 years ago. You look in Wikipedia, they say a nickname given to the oxyhydrogen process, and it's not a nickname. I discovered it. I get to name it. Ta-da! There, that's for history.
So can I ask one other question here, because it just doesn't seem to compute that when you put the flame on aluminum, it burns at what, 900?
Yeah, 900, slightly above the melting
But if you put
point.
it on a different substance, it burns at a higher temperature.
6,000 degrees.
Does anybody know why?
13,000 degrees Fahrenheit.
Does anybody know why?
No.
Wow.
It's got to be something to do with the molecular resonance and in a way, we think that there is that heat in the environment has to do with stuff touching stuff.
Right.
It really has to do with the electromagnetic fields of stuff.
It might actually do something that might have something to do with plasma.
But this is electrochemical plasma. It literally is. I am the father of electrochemical plasma.
And Nikola Tesla said it's not electricity, it's not magnetism. When mankind understands plasma, then he'll start knowing science.
Now, can you imagine? I've been looking for what I call volumetric or round math. Like, literally, Newton had to invent a type of math to even describe the trajectory of projectiles and differential equations and all of that. He literally had to invent calculus. I was looking for my volumetric or spherical or round math.
Because
now with computers, we can model this stuff now, because when you pressurize it, that changes the distance between its now expanded atomic structure and narrows it, which means now it detonates faster with more energy. So now you have compression as being a factor, you have the gas itself and its knowns being a factor, that changes its reaction with each material. So, I mean, I can
applying
show
a lower
you
level of
notebooks,
physics to something more
Right.
advanced just
I
doesn't
have
work.
notebooks of trying to differentiate and develop this round or spherical map, volumetric map, to describe what I was talking about. Now with computer modeling, they can take all those parameters in. They can say, okay, if you pressurize it, it's going to react in this way, because now it changes the way that it reacts with lighter materials. If you depressurize it, it won't ignite. And they can get all those parameters, and then they can actually, like looking at the sphere of the universe, they can actually show the patterns. You've seen that one done of the hiss of the universe?
No.
It's beautiful, beautiful. You've seen it?
Yeah.
It's a beautiful imagery of literally a picture of what the residual of the Big Bang looks. There's clusters of energy and open places of no energy. Dark matter, and it's all interplayed there. Now they're looking for dark matter, and I believe that that's a false look.
I kind of do too, but they said even if they do determine dark matter, there's still 2/3 that is not accounted for.
Right. See, this is available
dark
anywhere
matter.
because it can be present in a vacuum, and it is diamagnetic, so it is affected by gravity, much like water. If you put a magnet to a stream of water, you can pull the water aside with that magnet, so it's diamagnetic. So it has all those features, and I always have been putting forth the hollow sun theory, that in the middle of the sun is a very dense core. On the outside of the sun is a hydroxyl reaction. Now, a scientist cannot say that that's what it is because they've never seen a hydroxyl reaction, and they won't listen to me to take them there. And they won't even, if I put a torch in their hand, they're looking for something in the machine that's fake.
And they still say that the sun is not, that the sun is, with all the, that there's physics that they know, there's still another 1/3 of the energy is coming from somewhere.
Gravity.
Right.
But then what we know is the outside of the sun, not the chromosphere, but the outside of the surface of the sun is actually a homeostasis that expands and contracts. They will say that. It's going into a swelling phase and it's going into a contractive phase. But as the sun moves through, it's picking up all these materials and subjecting them to a hydroxyl reactive reaction. And that's what I see when I look at the sun. So if we move into a dusty part of the universe, our sun swells. If we leave that, our sun contracts slightly. But it also explains, you'll see later on if I can get you the DVD, how next to the flame there's hardly any temperature, but away from the flame we're in this conjunctive zone of the flame. It's like a laser. Its heat release is unbelievable and instantaneous. White hot. White hot. It's like that, like turning on a light.
This DVD, is it something you produced, or you
it's just old archive footage.
You live on a boat?
Yes, I do.
Tell us about your boat.
I picked this boat up. It was basically a work barge for about 13 years. A fellow lived aboard it in Vallejo Harbor, and he wanted to get rid of it, so I purchased it from him. And now we're thinking about trying to convert it to a mobile teaching platform where we teach as close to the earth and as close to natural green ways of producing everything we need, including water. People feel that water wars are coming, and we want a way to show that that's independent. Now, my work in science also parallels my work in understanding the way things work in nature.
So you have a way to, with this technology, prevent water wars? Is that what you're saying? Or,
yeah, I think so.
Yeah.
I think so. The other thing is we also can make it, if they try to make water a commodity more than it is now and actually raise the price of water, well, one, hydroxy is easily made from urine. Perfect. So unless they can control the effluent of your body, you're still independent for your energy needs. But to drink, what we want is the ability to show people literally hands-on, let them come aboard the boat, a simple process of taking a refrigerant system like an air conditioner out of a Mercedes, take the high side, the high pressure side, put it in a pan and evaporate salt water into a greenhouse that we want to put on the bow of the boat. In that greenhouse we'll have a series of long tubes that we have a chill tank that circulates just seawater, but chilled seawater through these long tubes forming condensation, where that drips off the bottom of this continuous looping of tubes all the way through the strong back of the greenhouse will be our water recovery system from the air, and also from some of the evaporative salt water that's in that lower tray. So we still maintain humidity in the greenhouse, but we're using the greenhouse moisture, the humidity in the greenhouse, to form our freshwater recovery for the boat.
Are there systems like this on land? Or is this a new...
Iced tea glass on 4th of July. It sweats. So I'll never teach you anything that you don't already know. It's just putting it together in pieces. So it works, like I say, the Mercedes out of the junkyard.
Yeah.
Is to keep it ghetto tech, so that anyone up there says, I can do that.
Well, the reason I ask is I'm thinking of things like the earth ships, that the architect that has developed the type of housing where a house could be self-sufficient. Some of the things that your ideas that you're describing would work equally well there, except for they'd have to have a different source of water.
Right. Well, you can make water from any air, even desert air.
Yeah.
Come the early morning hours, you go out in the desert and your sleeping bag is covered with the dew. So those early morning hours are a great time, like the creosote bush. It is waxy leaves that collect that mist, run it down the smooth bark right to the grass below it. And this was a vision quest of mine, to sit down before the creosote bush and say, how do you do it? So this is an extrapolation of that vision quest with the creosote bush, is the contrived method of using a Mercedes-Benz refrigerant system to take water from the air, just like the creosote does the mist of the desert.
Yeah.
So, but you look at that nice little bundle of grass under every creosote bush, and it's moist.
So what's the time frame you're
Probably,
working with, and what has to happen for this to?
Probably about a year to a year and a half. That has never sailed. It was constructed. The boat was constructed for about a little over $300,000 in 1972 by a doctor and his wife. The story that we have to date that we want to research is that the doctor's wife developed cancer. She passed away during the construction process, and he was rushing it through to get it done, but the two didn't match time-wise. And that was their dream boat, and that after her death, he grieved himself to death, and their insurance agent ended up with the boat. He kept it in slip, trying to find one or somebody from the family to take over the project, but none of them wanted the boat or the headache or finishing the project or anything like that, or had the capability thereof. I don't know whether they were childless or they just couldn't find a family member that wanted it. But he ended up with it, he kept it at slip, and then finally, years later, he sold it to the man who had it before me, and he had it for 13 years, and then I've now had it 5 months getting it ready, redoing some of the systems on board, getting solar systems on it for lighting and those sort of things. So we're just at the green, just the seed stage.
Just barely getting going,
Just barely getting going, exactly.
Can I interject one thing from outside here?
But it's paid for. The whole thing is paid for.
Okay. So you're not trying to stay above water, so to speak.
Exactly.
But you're moving forward.
Is that the ability of that system to generate water in the middle of the desert?
Yes. This
That's
actually
huge.
the Knudsen, if I could brag now, the Knudsen solar well could be used for military locations, observation points, remote villages, to provide them with clear fresh water right from the air. It's only dependent upon battery supply at night, solar panels during the day, and the recovery of air. I always envisioned it being used in remote locations for reforestation to do a fairly large unit. You could do 300 to 400 gallons a day, and that unit would then feed the little seedlings for reforestation until they could reach that critical 3 to 5 year period of time that they become viable to their environment, and then take the unit and move it to the next plot that you're trying to get started in reforestation. So,
well, there are these, just using this heat pump technology, there are devices that are on the market now that people are really interested in, to be able to collect water from the air and condense it. And you can plug a solar panel into it, and it can work that way.
But there, once again, in keeping with my ghetto tech drive, I wanted to where almost any country, anywhere, they don't have to buy something for $9,000 or $12,000 or $36,000. They literally could go to a junkyard and a hardware store and make it.
Yeah.
Or in very low level technologies.
Yeah, that's a real similar vision to the Earthship guy.
Yeah. Can you pick it up off the ground? Can you get it out of a salvage yard? Can you pull it off an old car and get everything that you need to make it work? And everybody be able to do that if they've got a little bit of wrenching skill, mechanical skill, mechanical ability, shade tree mechanic type technology. all about that empowerment at the least possible scale as possible. So that's my whole thing.
Awesome.
So anyway, now we make our own biodiesel from vegetable oil, and so we are off Exxon, off BP, totally independent that way from the petrochemical industry. Even our crankcase oils will be synthetic. We have a Ford Lehman, which is a beautiful diesel tractor engine, and we want to get a little Volkswagen or a Mercedes little small 4-cylinder engine for the diesel. We already have the generator, we just need to couple it to a small power plant, but we want diesel, so we can go biodiesel, all off petroleum.
So you're talking about the engines that are on the boat?
The engines that are on the boat, the motivating engine, and of course there's a sailboat that's like a huge motorhome with wings.
Yeah.
You know, it just flies where it wants to go.
But it actually hasn't been sailed yet.
No,
Anything else
it's
you
just
want to
a
say,
maiden
hanging
voyage
around
is
below,
coming up.
you haven't had a chance to say yet?
Well, on the boat, the other reason why I'm very happy that I got the boat is, one, it's an icebreaker. The hull is concrete and steel, and it's extremely thick and extremely strong, and it was built professionally. Not this isn't a backyard fair hull cement.
And it's a one-of-a-kind boat too, from what you said. It was a custom made?
Yes, yes. It's architect. We have all the blueprints and everything for its original design, construction. It was a Samson Marine design, Samson Marine Architects. So we have all of that documentation for the boat itself. It's actually a ship because our launch can fit between the masts and be loaded aboard by the main boom. So it really does qualify as a ship because it can carry a boat on it, other than like a dinghy. It'll carry a 17-foot launch to get people to and from shore. So we can even come into remote islands and teach them how to make water, not using the mechanical version of the, let's call it the creosote bush inspired system, but a passive solar system that uses seawater and a type of polycarbonate plexiglass where you just need one solar power pump to pump salt water into the field, and it passively makes fresh water from salt water. And your byproduct is salt that you can sell to rubber industry, to the cheese making industry, to all the other industries that use salt. So the day you fire it up, you've got a cash crop, let alone the fresh water that will save you from having to tank in water, bring it in on a tanker ship, which some of these islands do. So we can anchor off, go ahead, show the people, teach. Like I say, it's a mobile teaching platform to do the water farm is what that's called, because it looks like a farm. About 5,000 acres, or 5,000 gallons per acre per day, with a passive solar, one simple pump just pumping that water up there, and a solar powered pump at that.
The thing that I'm struck with is that the scalability of this. We tend to think that in order for us to be an advanced civilization, we have to have huge factories.
Right.
We don't need huge steel factories. The fact that you can have this little foundry and, you can make
let's say boutique steel, you know, for this scalpel, or for this jewelry, or for whatever reason. Also, I think it's wonderful for sacred jewelry is because there's nothing polluting in the fuel to be entrained or included into the steel or silver or gold, is that whatever you end up with is the purest quality that you can make. So for I guess you would say traditional pieces of votive art, you can say, or artifacts and for their type of magic, as far as that is concerned, they've got absolutely pure. There are no, well, I call them the clock people, the worry people, the people who rush to work and everything else. There's none of that world in that product.
I see what you mean. Okay.
So you have the purest product to put impart your mana, if you want to put mana, into when you're making the jewelry, so that when you pass it on to those that would use the jewelry, it is pure. So glass beads, crystal, all the other technologies that are being brought to bear on healing and carrying forth power are now off that grid.
It's really from the ground up.
Exactly.
Yeah.
So, but the scalability of it, you can make an ounce of steel, a pound of steel, a ton of steel, or 1,000 tons of steel, as you choose, and all using solar power and water. The criticism is, well, what do we do with the other 2 shifts? Well, you have them clean up or prepare for the next pour of the next day, because it's so hot that you can bring your furnace up to full temperature with no pollutions, and do that in just a matter of an hour or so at the beginning of the day. So your bar mill is up in operation by 9 o'clock in the morning.
You don't need to make people work
24
the way
hours,
that the rhythms of their body shouldn't not work.
But the criticism was, and I said,
wonderful.
They said, what do we do with the other 2 shifts? And I said, send them home to be with their families.
Yeah.
Let them sleep. Let them get rest. Be in their circadian rhythm, whatever it is. They're early people and late people, so they could cross 2 shifts, have cleanup and preparation, the dolomite
Night
troughs.
shift is bad for your body.
Dolomite troughs for the delivery to each bar slab, a pour, or whatever they want to do. They can do that during those off hours. And they said, well, we have battery. And I said, no, you wouldn't want it. Why do you need it when you can fire up a huge furnace?
We just tend to think that we have to keep doing things the same way that we've been doing it without.
Even though you've got a totally new technology, they go, well, our foundry takes this much thermal units. And you're going, yeah, that was before. Well, plus the intellectual inertia around this is unbelievable, because of course if you go to a thermal scientist, and he's been in the combustion industry for years, you know, making furnaces and designing furnaces and everything, he doesn't want to know about this, because this puts his entire existence at threat. Rather than saying, wow, how can I adapt to this and I can go into this new
we should see it as freedom.
Of understanding.
The extent to which we resist stuff like this is the extent to which we're in bondage to something that's enslaving us.
But we do it to ourselves. We don't want to see what is naturally there. And we don't want to understand what is naturally there. So it's really kind of...
There's a book I read years and years ago.
I call it academic inertia.
Yeah, it is. It is. There's a book called Small is Beautiful by Eric Schumacher. You know, I read it years and years ago, and I've got it again. I've got to read it again, because I know when I read it, this is right. This is the right way.
Well, also, you got to think of the power of a Chinese concept called the 1,000 hands concept. The easiest way for me to talk about it is like Velcro. One of those little hooks does very little. You can pull it loose. But you put all those hooks together, and all of a sudden you've got something of great strength. It's like the weave of fabric. One strand or one thread is fairly strong, snap. Right, but you weave it together, and now you have something that you can bend steel bars with. You know what I'm saying? By twisting it and turning it, and rope itself.
And when ideas like this permeate a culture, there's no stopping it.
Exactly, exactly. And look at what has happened to the textile industry, which is basically tying knots, when you think about it, which they say was the first technology given to mankind, was the ability to tie knots. You got fishing net, you've got linear knot of a twisted rope, you have the trucker's hitch to use compound advantage, compound mechanical advantage to tighten down a load on a truck. All these various knots for all different things, and literally weaving is a type of knot making in sequence. And then you can put in patterns like the Jacquard loom. You've got all the wonderful patterns of the Jacquard loom, the forerunner of the computer, as far as programming. You know, it was a card-driven programming system. So that I believe that that's true, because literally taking fiber, grasses, and twisting them and looking at them was literally the first type of technology that we got around. Pretty soon they were making rope, or they were making clothing, or they were making a shelter, and interweaving and basket weaving would be an example of knot making in general, knot making in a sphere, or semi-spherical way. So carry things, you know, when you've got like 2 hands, you've got 3 rocks in this one, 3 rocks in that one, and then you got the kid looped over your arm.
Make something to put this in.
Make something to put this in. We got basket weaving, which is knot making. In fact, my name, Knut, is a derivative, or Knudsen, is a derivative of the word knot.
Okay.
So, Canute, C-A-A-N-U-T-E. And King of England, so, or conquering King of England. So 1016, look him up. He's a very nice fellow. Get the profile and compare it to the one on the coin.
got the profile.
Sure.
Great to be with you.
Great to be with you.